Hello students, welcome to CBSE Science series. We already studied about electric field in the last video. And in the last video, I made a mistake that I told attractive forces due to like charges. No, the attractive forces due to unlike charges and the repulsive forces due to like charges. Kindly note that mistake. Now, how can we define the electric field? Electric field is the region or a space around a charged body or a charged particle in which another charged particle experiences a force is known as the electric field. And the electric field around a charged body or a charged particle is not same. It is different at different points. Now, how can we measure that electric field at a particular point is known as the electric field strength, electric field intensity, or simply electric field at that point. How can we measure that? By placing another charged particle, that is a test charge. When we place a test charge in the electric field, the electric field of the source charge produces force on it. So this way we can calculate the electric field at that point. It is nothing but force per unit point charge is known as the electric field at that point. How can we denote that? E vector. E vector is equal to F vector divided by Q naught. That is force per unit test charge is known as the electric field. And from this we can calculate the force also, electrostatic force between the source charge and the test charge. If we know the electric field of the source charge, the electrostatic force is E vector into Q. And here we have written that the limit Q tends to 0 because we know that we make Q naught as very small because the Q naught also create electric field around it, and due to that electric field, source charge experience a force and it tends to move out of its location. So we can't calculate the electric field of the source charge. So that we make Q naught as very small. If we make Q naught as very small, the source charge experience small negligible force from the Q naught and it remains at its original location. So that we have written E vector is equal to limit Q tends to 0 force per unit charge, that is F by Q. And electric field is a vector quantity, means it has magnitude as well as direction, and its SI unit is Newton per Coulomb because SI unit of force is Newton and the SI unit of charge is Coulomb, and its direction is same as that of the force exerted on the point test charge.